A dashboard is a data visualization that aggregates metrics in a way that we can quickly understand. In a modern software company, everyone uses dashboards, from salespeople to DevOps to HR. Each dashboard represents a query that must be updated frequently so that anyone looking at it is getting up-to-date information. The data that's being ingested and turned into a dashboard might be getting updated really quickly in the case of time series or log data. Some of the queries might require joins between disparate data sources. So building a dashboard is not necessarily an easy task. How do you keep the dashboards accurate? How do you keep the query latency of every dashboard down? Tom O'Neill is the CTO of Periscope Data, a company that makes popular dashboarding tools. In this episode, Tom explains the data engineering that underlies Periscope Data. We explore topics such as caching, columnar data, and Redshift. We've done many other shows about data engineering, including shows about how data engineering works at companies like Airbnb and Giphy. You can download the Software Engineering Daily app for iOS to find all of our old episodes, and they're organized by category. We have a recommendation system that will give you recommendations based on what episodes you listen to and upvote within the app. You can upvote those episodes and find new shows that you might like based on your listening history, because with 600 episodes, it's kind of hard to find the episodes that appeal to you easily. And we hope that the app helps with that. We also have a search engine within the app, so you can search for topics that might appeal to you. The iOS app is an open source project, and it's the first project to come out of the Software Engineering Daily open source community. There are more projects on the way. The community is growing, and if you want to contribute yourself, you can go to github.com/softwareengineeringdaily. We've got a Slack channel that's hopping, and we're working on an Android app, the iOS app, recommendation system, a web front end. Whoever you are, you probably have something that you can contribute to Software Engineering Daily's open source app ecosystem, and we would love to have you. We're trying to build a new way to consume software engineering content, and it's all at github.com/softwareengineeringdaily. Thanks for listening, and let's get on with this episode. Square is a complete omni-channel payments ecosystem where developers can create a powerful commerce solution. You've seen Square around at your favorite coffee shops and retailers, and it's trusted by millions of businesses for its simplicity and reliability. But as a developer, you can unlock the potential of a full payments and business management platform with Square's APIs at softwareengineeringdaily.com/square. There are APIs for online payments, taking in-person payments with Square hardware through a custom app that you build, and even inventory and employee management and sales reporting. Businesses of all sizes use Square's APIs to take payments securely online, in-store, and on the go with a single solution, and integrate with back-end systems that they already use. Check out Square's developer portal for all the tools that you need to get started today. Take Square's commerce solutions beyond the coffee shop and power payments for any type of business by going to softwareengineeringdaily.com/square. It's a really flexible platform for building a business with payments and everything else that you need to get started with a business, and you can check it out at softwareengineeringdaily.com/square. That's softwareengineeringdaily.com/square, and it would support Software Engineering Daily. So thank you, Square, to being a new sponsor of Software Engineering Daily. Tom O'Neill is the CTO and co-founder of Periscope Data. Tom, welcome to Software Engineering Daily.
Thank you for having me.
Today I want to go through the discussion of what Periscope Data offers in terms of the abstract product category, which is dashboarding tools, visualization tools, and then we'll get into the engineering of Periscope Data, what makes the product unique, and we'll talk about the company a little bit, Starting at that high level product perspective, a dashboard is a visual representation of data. What role do dashboards play in a modern technology company?
It's really about the culture you're trying to build, right? If you want to build a data-driven culture, the only way to do that is with data and showing that data around the company. And so the more you can get data out of sort of back-end servers and into the hands of decision makers, the faster your company will evolve to making better decisions.
And dashboards are created just for internal use, or can they be part of an externally facing product feature?
Oh, both for sure. In fact, in Periscope, we allow our customers to embed dashboards they build in the product in their own products, so that as they do their internal analysis, they can make that publicly accessible through their own portals.
Okay, so how are dashboards created?
They really start from a business need. Like somebody in management or in leadership wants to know what's going on with the churn, or where new revenue is coming from, or what to invest in. And that generates a bunch of work to figure out what is this spike in existing metrics, or figure out new metrics to record and analyze. And then from there, you build a dashboard, which at the end of the day is really a story, much more than a graph.
So there are salespeople, there's marketing people, there's HR people in a technology company. They're all getting more data-driven. But do these non-technical people, or at least traditionally non-technical people, do they know how to write a query to turn their question into a dashboard?
More and more so they do. In fact, we sell into very technical teams at companies. And one of my favorite stories is at an early customer. They're a video game company. And we sold into the marketing team, who was primarily building analysis with Excel. And one of those marketing analysts sort of fell in love with SQL and the product, and over the past couple of years has become an expert analyst and now runs their data team. And so through that sort of exchange, you can really elevate from just being able to do pivot tables to doing really advanced analysis.
So what's the difference between how a salesperson or a marketing person and an engineer, what's the difference in how they want to use a dashboarding product?
I think it really varies by data source. Right? A salesperson probably wants to look at Salesforce data. A marketing person wants to look at their funnel and the campaigns and how leads are tracking. And engineers are going to want to either look at product metrics or server metrics. And at the end of the day, they all might use the same visualizations, but the way you get from the raw data to that sort of ready dashboard is very different.
All right, so give me a high-level product view for what is needed to actually build a dashboarding product.
Okay, so dashboards are actually one of the later stages. It starts with ingestion, right? You have to get the data from somewhere because no data is born in a warehouse. And so once you build the ingestion part of your data platform, you get it into some kind of warehouse, and there's many good options for that. And then once it's in the warehouse, you do a lot of modeling and analysis. And that's where you convert basically unstructured or raw sort of columnar data into things that actually matter to the business, right? What is a user? How do you define a subscription? And then from there, you do further analysis to answer specific questions. And that yields your visualizations, and those visualizations become a collection on a dashboard.
And what kind of visualizations do you need to offer for this data?
You can actually offer a pretty small set. So the hardest part of data is turning something really complex into something really simple. And so by limiting yourselves to only using like bar charts and line charts and area charts and things like that, it really helps make the narrative understandable to a wider audience. Whereas if you invent really, really crazy visualizations to explain something very specific, you might not get your message across.
Now, there's a lot of different data sources to pull from these days. You've got basic SQL tables. You've got Amazon S3. You could consider that a data source. You've got Apache Spark. You've got all these different sources. So is there a lot of work to be done in building connectors to all these different data sources? If you want to make it easy for your customers to ingest the data and put it into a visualization, how much in the way of connectors do you have to build?
Yeah, the connector ecosystem is pretty crazy. It's certainly dominated by a head, right? There's your core SQL products, your core SaaS products you want to connect to, and then a very long tail of all the sort of random SaaS products that exist, and of course all the sort of one-off data sources. And so what we do is we supply connections to the core most popular like data sources, and then support an ecosystem where partners can plug in data from any other source.
So tell me more about how that ecosystem works, the data connector ecosystem.
Sure. So I guess ideally you don't want to write like the connection to Salesforce more than once. There's not sort of value in the world for 100 companies to write that same connection because the Salesforce API is pretty static. And so I think the interesting part is once someone writes that code, how can you reuse that and get that data into all the places where it makes sense to do analysis?
Okay. So let's say you've got a connector built, you've got a visualization tool going. How do you test that the visualizations that you're presenting are rendering that data correctly?
So testing in analysis is actually really hard. It's much harder than in normal software engineering. You can do unit tests on like schema validations and data validations, like to make sure there's no nulls or that a column is unique. But making sure that the actual data rendered in the output is right really takes like human validation. And so it's the equivalent of a code review from like a secondary analyst to make sure that the assumptions you've made and the decisions you've made in your SQL make sense.
So there's been a lot of generations of these data visualization tools, BI tools, dashboarding tools. I want to ease our way towards a conversation around what differentiates Periscope data. Why is there so much churn in this area? I mean, 5 years ago or 6 years ago, Tableau was all the hotness. 3 years ago, maybe it was something else, and then now I think I read a lot about Periscope data being quite popular. Why is there so much churn?
Sure, yeah. So there's two halves, the technology and the people. The technology being that these massively parallel systems are now possible to build, right? The Redshifts and the Snowflake. And the other is that professional data teams didn't exist until recently. And so now we have these people that are trained and able to operate such complex systems to do more complex analysis.
Okay. And the broader technological ecosystem, the companies that are getting started today, in many ways, they are reflections of what a Microsoft or a Google had in their infrastructure and in their tech stack maybe 5 years ago, 6 years ago. So, you hear about Google infrastructure for everyone. That's typically referring to Google infrastructure 8 years ago for everyone today. And I think that probably extends to data analysis tools and everything. So Periscope Data was started in 2012. What did the state-of-the-art data analysis tools look like back then? I think you were at Microsoft then, and you were looking at this ecosystem. You were saying, well, the internal tools here are so much better than the external tools. Maybe this is a business opportunity.
Yeah, very much so. The tricky part with the internal tools is that they tend to be very specific to internal data sources and internal workflows. And so the challenge was not to come out and invent a new kind of pivot table or a new kind of drag and drop product. The challenge was to come out and say, okay, we know what's possible. We know it's possible to analyze terabytes and petabytes of data very, very rapidly using sophisticated tools. How do we do that for modern businesses instead of just internal like search and ad sources?
Can you talk a little bit more about that? Give a little more color?
Yeah, sure. So the internal tools at Bing and Google were based largely on SQL, right? SQL is a natural language for doing sort of core analysis. And those tools were very much like some of the tools you see today with these massive clusters of compute and the separation of storage and compute. And so the challenge wasn't, could we invent that? The challenge was we knew it could exist. And so how do we make it possible for modern businesses to leverage that scale of technology to do the analysis that we knew was coming? Because even if they only had gigabytes or terabytes today, like petabytes is going to happen tomorrow.
Yeah, and I think so. Around this time, I'm trying to put myself back in 2012. I guess this was around when people are getting on board with Hadoop. I mean, people are still getting on board with Hadoop today. But if you're a data analyst or a marketer, data-driven marketer, and you wanted to get a question about the biggest data answered, you would have to go to the data warehousing expert and ask them for the Hadoop job, the Hadoop results for X. So that was like the early. I mean, we think about that now, and it probably sounds pretty archaic to a lot of people because I think a lot of the data infrastructure has become a little more self-serve for people in marketing, for example. So did the companies back then, like the startups back then, for example, the types of companies that want to take advantage of a Periscope data today, did they have the data volume problems, or did you just see those on the horizon, and that was what kind of made you think, okay, they're going to need some data analysis tools that can do this kind of clustering and so on?
That's a good question. If we're looking across our customer base, data volume doesn't correlate with company size or age as much as you might think it would. We've seen like 5-person video game companies with billions and billions of rows of data flowing in every day, just because they're operating a popular game and it's instrumented so thoroughly that the event streams are really, really dense. And of course, you have older companies who haven't instrumented an even more popular product all that well, and you're just dealing with like a replica of their production database, which might only have like 100 million rows in it.
So can you give me a little bit, I don't typically ask about the company backstory, the origin story, but I think it's particularly interesting in Periscope Data. Tell me a little bit more about the origin story, like when you were at Microsoft and I think your co-founder was at Google. Give me the diff between that scenario and when you guys ended up starting Periscope Data.
Sure. Yeah, so Periscope was not an idea when we got started. We were college roommates and we graduated and we went off to Google and Microsoft, and it was a someday plan. Like someday we would start a startup. And 3.5 or so years later, my co-founder Harry calls me and says, "Hey Tom, I quit my job. I'm moving with my backpack and my girlfriend to Southeast Asia. Let me know when you're ready to move down." And so like that was a pretty strong like, okay, yeah, like now's the time. And about a month or two later, I'm driving down from Seattle to San Francisco, and he and I get started. And we worked through a bunch of ideas, turned out to be terrible ideas, sort of these solutions in search of problems ideas. And we come to an idea, the one just before Periscope, that worked. And it was a mobile app, and it was pretty successful. It got many thousands of users, and of course, a lot of data associated with that. And we wanted to know what our users were doing. And when we looked at the tools at the time, they were very they drag and drop, right? Renders and dimensions, and it's like, what's going on here? We just want to write some code and see our data. And so we invented Periscope for ourselves in the model of what we had seen at Bing and Google. And that actually began to take off because some friends saw what we were building and were like, "Hey, can we have this at our business?" And we're like, no, it's a side project, don't worry about it. And yeah, this happened a few times, and folks were like offering to pay us for this side project. And we're like, okay, this is real. Let's do this. And so that was the genesis of Periscope. And it took us probably 1.5 years after realizing the side project was clearly super valuable to turn it into the V1 that ended up getting like product market fit and really taking off.
Amazon Redshift powers the analytics of your business, and Intermix.io powers the analytics of your Redshift. Your dashboards are loading slowly. Your queries are getting stuck. Your business intelligence tools are choking on data. The problem could be with how you are managing your Redshift cluster. Intermix.io gives you the tools that you need to analyze your Amazon Redshift performance and improve the tool chain of everyone downstream from your data warehouse. The team at Intermix has seen so many Redshift clusters, they are confident that they can solve whatever performance issues you are having. Go to intermix.io/sedaily to get a 30-day free trial of Intermix. Intermix.io gives you performance analytics for Amazon Redshift. Intermix collects all your Redshift logs and makes it easy to figure out what's wrong so that you can take action, all in a nice, intuitive dashboard. The alternative is doing that yourself, running a bunch of scripts to get your diagnostic data and then figuring out how to visualize and manage it. What a nightmare and a waste of time. Intermix is used by Postmates, Typeform, Udemy, and other data teams who need insights into their Redshift cluster. Go to intermix.io/sedaily to try out your free 30-day trial of Intermix and get your Redshift cluster under better analytics. Thanks to Intermix for being a new sponsor of Software Engineering Daily. So, when people hear data visualization, I think that their perspective is that this is mostly a design problem. This is like you're building stuff on top of D3.js and you're just making interesting visualizations. But actually, in between the data source, the database, and the front-end visualization that you can just load up on a web page, there's a whole lot of middleware, or what I don't know if you want to use the term middleware. I'm going to use the term middleware. Data layers, intermediary data layers, caching layers that are necessary to get good performance. And the thing is, performance in a data visualization is really important because you don't want to be seeing the data from 10 minutes ago. You want to know what kind of monitoring problems are existing right this minute. So query latency is a huge deal because every data visualization is essentially a graphical representation of a query. And so query latency is going to be your bottleneck in many cases. So if I have a dashboard, and that, let's just say broadly speaking, not talking about Periscope data specifically, let's just say abstractly, I've got a SQL database and I have a dashboard that is pulling from that SQL database, and that dashboard is slow to load. What are my options for speeding up that query?
Yeah, so there's a few different places where it could be slow, right? It could be standard, like web server is slow. That's easy enough to fix. But where it gets really interesting is if at the end of the day, the query you're running to populate the dashboard is itself slow, it's a query that takes 10, 20, 30 seconds, really the way to do that is to either through hardware or through pre-processing, like through modeling. And so with hardware, of course, you can get bigger clusters, bigger columnar distributed data stores. And with pre-processing, you can do roll-ups, right? You don't need to calculate yesterday's daily active users over and over again. You can calculate it once and save that and only calculate like today's to save a bunch of time, for example.
Okay, what about caching? What are some of the different caching strategies, other caching strategies that you can use to speed up queries? I guess what you just described is kind of a type of caching, but talk a little bit more about caching.
Yeah, so you can cache at different layers. Of course, you want to cache the results of charts themselves, right? So when you reload the dashboard, you populate the previous results in immediately, and you can refresh the old results in the background. But what I think you're referring to as caching is how to get the data into the warehouse, right?
Well, I was talking pretty abstractly, so yeah, we can go ahead and talk about caching into the data warehouse.
Yeah, so as we discussed before, data isn't born in the warehouse, and so you want to get it in there. And sometimes it's really easy, right? There's just an event stream, it's an append-only type table, and you can grab the new rows incrementally. That's the most straightforward approach, just streaming data right into the warehouse. Where it gets tricky is when you want to load your users table into the warehouse from like a prod replica. And now the users table isn't append-only, it's getting new rows, of course, but old rows are also changing. And so the tricky part is figuring out how do you identify the rows that have changed and update those in the warehouse as fast as possible. Because it might not be reasonable to reload the whole users table over and over again, like every 10 minutes.
Tom, I think there are people who are listening who don't know a whole lot about the difference between a data warehouse and a production database. Can you give a little more color on the difference between those two things?
Sure. So just for the sake of the example, we'll compare Postgres to Redshift. Redshift uses a similar dialect. It's based in Postgres 8.4, and so the differences will be more obvious. So Postgres is a row-based store. When you look up a user's record, right, select star from users where ID equals 5, it can do one seek on disk because all the columns in the users table are stored next to each other. In fact, the whole users table is stored in one flat file on disk. And that makes it possible to use multiple indices on the same table, use primary keys in that way to hop down to a certain row, and really load up a single user really, really fast. But if you wanted to find the users with a certain birthday, right, and you didn't have indexes, for example, you'd have to scan the entire table, right? Birthday is not a column to typically index, and it's okay to find the minimum or maximum birthday, you have to look at all the user records. And doing that means reading the entire table because you can't just read the birthday column because it's stored in a row-based store. That's typical for the kind of database you would use to host a website, for example, because you generally don't care about all the users, you care about one user at a time. Mm-hmm. Warehouse is quite the opposite. Warehouse queries almost always care about all the rows, but only a few columns because most queries. And so in that case, each column is stored in a separate file, right? You'll have the birthday column in the birthday file, the ID column in the ID file, and it means you can't use indices in the same way you would on like a Postgres database because the files are distributed across the nodes, but you can just read one column's worth of data. As a bonus, because you're only storing a single column per file, you can split the file into many chunks and distribute it around the cluster, and then zip those chunks because it's all the same data type. It's all integers or all dates.
When you say zip, you mean like just like a distributed query, like pulling them all together, or what exactly do you mean?
No, like gzip. You can actually compress the data because one of the biggest factors in database and warehouse performance is I/O, right? And so with a row-based store, you want to read the whole row contiguously, and in a warehouse, you want to read the whole column contiguously.
Right. No, I get that. I'm just a little confused on the zipping part. Why is zipping unique to the data warehousing side of things?
When the column is all the same data type, all integers or all dates or all strings,
okay.
You can literally just compress the file.
Okay, right. Because if you're doing compression, you're always going to get a better, compression ratio the more common the data within the corpus of compression is.
Correct.
Right. So for people who don't know much about this columnar versus row-based form, we've done some shows about this in the past. We did a show with a couple guys from Dremio, which is kind of a stealth data company. But just to put a little more color on this, because I think some people are still probably a little unfamiliar with this. If you've got a typical user database where you've got types of data like age, name, last date of last login, those
Sure.
are all different columns in a specific row. And so Tom's row is going to include his age, his name, and so on. You can take that database and reconfigure it as just the rows of the database. So you just have all the ages of different users, but you don't have the other data associated with that particular user. And the advantage of that is if you wanted to do something like chart the ages of the users in your database over time, you don't need there's a lot of data in the database that you don't even want to look at. And so internally, when a database, if you just have a naive SQL database with all of those columns in it, then a query is going to take a lot longer because it's got to hop over those areas that it doesn't care about, as opposed to if you have a columnar database, it can focus explicitly on that data that you're concerned about. Am I articulating that correctly?
Exactly right. And you can see the difference in the performance characteristics of very simple queries. So if you did select star from users where ID equals 1, a basic like give me all the information for user 1 in my database, that'll be like 1 millisecond in Postgres, but that could take 30 seconds on the Redshift because it has to open so many different files and the data is spread all over the place. Likewise, if you wanted to sum the ages of all your users, that could take a long time in Postgres because it has to read the whole table. But in Redshift, it could be nearly instant because it will just read the age data.
Mm-hmm. Now, customers that come to Periscope Data and they're like, okay, I want the dashboarding tool du jour, the best dashboarding tool that's available. I'm going to get Periscope Data. Do they typically have Redshift already in their infrastructure, or do they just have a SQL database and Periscope takes care of pulling that SQL database into Redshift? What's the prototypical infrastructure that the customer comes to you with?
It really varies by the data maturity of the company. And so you'll have companies who have many different databases and want to join across them. So they don't already have an internal sort of ETL pipeline set up. And so Periscope can help with that. And likewise, we'll have customers who already have pretty sophisticated data pipelines and just want to use Periscope as a modeling and visualization layer on top.
Okay, so talk a bit about like people who come in, they don't have Redshift, they just have got a SQL database. As I understand, you will pull their database into Redshift to get a caching layer. Is that correct?
Right. Yeah. Building a viz sort of system, an ETL system on top of a regular sort of production class database like a Postgres or MySQL can be pretty difficult because the performance really breaks down as your queries get more advanced and data volume goes up. And so what we do for customers before they start building dashboards is we'll mirror in all the data from their various databases into a single Redshift database. And with that, they can do their modeling within Periscope and, of course, join across all the different databases and build dashboards from there.
And talk more about that ingress, like what happens under the covers when the customer comes in and you're going to pull their database into Redshift.
Yeah, so it really is something we'd set up, the customer sets up per table. They decide how they want to sync in their data, how much of their data they want to sync in to sort of our backend. And that can run on any schedule they like based on how their own internal processes run. And some customers like to do nightly jobs. Some customers want the data up to the minute, depending on how the origin data source is working. And of course, there's priorities between which data source sort of mirrors into the Redshift on which schedule.
Can you talk about some of the challenges of getting that process right?
For sure. I think one of the mistakes that can be made is, at least with other products, is they try to do the modeling on the fly. Right? You have an origin data store, you try to model it and then put it into a warehouse, and you're never really quite sure if the error that you find later on is due to not getting the right data, or is it an error in the modeling layer that has sort of no tests around it, or is there a problem with the analysis? And so what we focus on is mirroring the exact schema, right? All the columns, all the rows, everything that you have shown to Periscope, we mirror it in. So you can know with 100% certainty that the warehouse is starting from a good place. And then when you build your modeling layer, you can make sure that those models are accurate based on known good information.
And how, I guess, describe a little bit more about why that process helps with query latency for people who haven't made that connection yet.
For sure. It really has to do with how much hardware we have behind the scenes. Right? If you become a Periscope customer and you have a couple billion rows of data, maybe it's stored in a MySQL database, your queries are probably taking several minutes to do the basic things like daily active users and retention and churn. But we're going to mirror that into our Redshift clusters. And we have thousands of nodes and about 25 terabytes of RAM across all of our clusters that make it possible for us to do those same queries, sometimes sub-second.
So if I'm a user and I've got these queries that I want to run, that I want to turn into dashboards, what kinds of caching are you doing specifically for the queries that I've got set up? So let's say I want to have a query that's got the active users on my website at any given time. Does that change the underlying infrastructure? Does that change what you are caching more aggressively in Redshift?
In that case, we'll certainly be caching like your activity tables much more aggressively, right? Because we want to get the activity data in as fast as possible. But there's also a bunch of modeling going on behind the scenes because activity is not the same as an active user. You might want to scrub out like your own internal users. You might want to scrub out test and development users. And so you want to layer between the raw data source and the visualization that lets you define what is a user, what is an active user, and then graph that instead.
Why are you using Redshift? Because I feel like I've started to hear more and more about Redshift. I guess people have been using it for a while. I have not reported on it very much, but it seems to really be the data warehousing tool that is most popular. Explain what makes Redshift so useful.
So Redshift was one of the first like truly hosted, like managed warehouses where you could throw data at it and it will help you scale to quite a bit. And so we invested with the Redshift team quite early. We're on a first name basis with many of the folks over there. And it's really been a fantastic partnership working with them to sort of scale our use case along with scaling their infrastructure and their roadmap. And so while there are definitely other data warehouses out there that do a good job, right now for us and our customers, Redshift is the best fit.
And are there any? So I guess the pricing is not an issue for you because I hear that sometimes when companies are using Redshift and this is true for just cloud in general, sometimes the economics of their business are such that it's hard to justify using the expensive cloud infrastructure. But it sounds like the cost is really not an issue for you.
Yeah, at scale, the cost really works out for us. And something also to keep in mind is you really don't want to treat all your data equally, right? Some data should be in cold storage. Some data should be in S3. Some data should be pulled from S3 when it is needed into a hot resource like Redshift. And so you want to tier your data lake so that you're cost effectively using your storage and your compute.
And how much tuning does the user have to do of Redshift?
If they're using Periscope, they don't have to do any tuning because we handle that all behind the scenes. If they're using Redshift on their own, then they want to be setting up sort keys and disk keys, which affect how data gets distributed around the cluster. And then, of course, doing all the usual database maintenance like vacuuming and analyzing on a regular basis.
And when a user comes to you with their data and it's not in Redshift, is the Redshift configuration, the caching layer that you build for them, is that all done automatically, or are there cases where you have to go in and do some manual stuff?
We generally don't have to do anything manual. The customer just sets up a schedule of how they want to mirror their data in and on what frequency.
And how are the APIs for Redshift? Because it's kind of cool that you've been able to build a business around this product. I thought of Redshift as more of a something that a company would just use sort of internally to do data warehousing queries, but this is like a case where you're actually really using it as a core piece of infrastructure to build on top of in an automated fashion.
Yeah, so like all AWS services, Redshift has a really thorough API and sort of how you interact with it and how you interact with scaling and creating new clusters. And of course, Redshift itself is just a database. And so when you're communicating with it, it's just a JDBC driver and then normal SQL.
Is pricing an interesting discussion here? Like, I imagine, figuring out the right way to price a user so that they don't get burned on the cost too much, but also you don't get burned on the cost too much. I imagine that's tricky. How did you arrive at the right pricing?
Yeah, it's especially tricky for us because Periscope is a platform. It's not just a visualization and dashboarding tool. It also includes this warehousing component. And so there are really two halves to the pricing model because we want to tie the value of the product to the value that the customers see in the product, and not at all based on like costs, because that's not how you operate a pricing product. And so from the warehousing side, we charge based on how much data volume you're using. Right? And that correlates to how much value they're getting out of the warehousing half of the product. And of course, on the Viz side, we charge based on seats. So how many users are actually using the product and getting value from either building graphs or consuming graphs.
Who do you use for log management? I want to tell you about Scalar, the first purpose-built log management tool on the market. Most tools on the market utilize text indexing search, and this is great for indexing a book, for example. But if you want to search logs at scale, fast, it breaks down. Scalar built their own database from scratch, and the system is fast. Most of the searches take less than a second. In fact, 99% of the queries execute in less than a second. That's why companies like OkCupid and Giphy and Career Builder use Scalar to build their log management systems. You can try it today, free, for 90 days if you go to the promo URL, which is softwareengineeringdaily.com/scalar, SCALYR. That's softwareengineeringdaily.com/scalar. Scalar was built by one of the founders of Writely, which is the company that became Google Docs. And if you know anything about Google Docs history, it was quite transformational when the product came out. This was a consumer-grade UI product that solved many distributed systems problems and had great scalability, which is why it turned into Google Docs. And so the founder of Writely is now turning his focus to log management. And it has the consumer-grade UI. It has the scalability that you would expect from somebody who built Google Docs. And you can use Scalar to monitor key metrics. You can use it to trigger alerts. It's got integration with PagerDuty. And it's really easy to use. It's really lightning fast. And you can get a free 90-day trial by signing up at softwareengineeringdaily.com/SCALYR. softwareengineeringdaily.com/scalar. And I really recommend trying it out. I've heard from multiple companies on the show that they use Scalar, and it's been a real differentiator for them. So check out Scalar, and thanks to Scalar for being a new sponsor of Software Engineering Daily. When I'm sitting in front of my dashboard throughout the day, so if I'm a marketing person or a salesperson and the traffic patterns on my website are vacillating throughout the day, they're going up and down, I imagine that's putting different types of load on the data infrastructure throughout the day, and that's going to propagate to the query latency, the naive query latency of my dashboard. How does the Periscope data infrastructure adapt to the burstiness and the spikiness and the change in traffic patterns throughout the day?
That's a really good question. For our Redshift clusters, they tend to be multi-tenant. So we'll put multiple customers onto the same hardware, of course, separated very specifically for security reasons, but they're on the same physical machines. And we don't put all the customers in San Francisco onto the same cluster. We have customers all around the world, and we have B2B customers and B2C customers, and those usage patterns are different. And so what we actually do is we balance the time zones and the use cases of customers on each multi-tenant cluster so that customers can timeshare a supercomputer and not compete with each other that much.
All right, well, let's get into more infrastructure discussion. So we've talked a little bit about the connection between visualizations and caching. I want to get a better picture for the infrastructure, how you service user requests, how you scale. Just give me a picture for how your infrastructure looks.
Yeah, so most of our infrastructure in the backend are Go microservices. And so they operate and they sort of talk to each other through various APIs, and they're managed by Kubernetes. Of course, the front end is all JavaScript.
Okay, so Kubernetes running on AWS?
Yes, that's correct.
Okay. Is there anything interesting there? I mean, because if you started in 2012, you must have gone through a migration to Kubernetes. What were you on before Kubernetes?
Oh, the days before Kubernetes were not good days. We were doing a lot of manually and scaling in ways that were a little rusty around the edges. But now with Kubernetes, the system is much smoother.
Can you tell me any nightmare stories about that?
I can tell you about one of my favorite microservices. It was originally called the sorcerer because it stores data sources. And it was built in a world before Kubernetes, before horizontal scaling. And so it was one box storing all of the chart data because we would store chart data separately from like the production database or the warehouse. And as we started scaling like well past 800 customers, like it became obvious that this server was not going to keep up. And of course, you don't want to have all your chart data like stored on one server. This is not a good system. And so one of our engineers, she took over the project and she built what is now called the sorceress. So along with upgrading and becoming horizontally scalable, the microservice had a gender change. And now it is much more performant, and it does a really, really good job for our customers.
Oh, that's great. So what are the other SaaS tools and the infrastructure tools, maybe the cloud services that you're using throughout your infrastructure?
One of my favorite tools is Scalar. We stream all of our logs to it, and it helps us with production monitoring and alerting. My favorite part about it is like search is instant. Like you can query a week's worth of logs, which for us is a lot of logs, and the results come back almost instantly.
And how does that compare to how you were doing logging? But I guess, as a caveat, I should say Scalar is they're about to become a sponsor of Software Engineering Daily, so that's cool. But not as like sponsored content. Like, how does that compare to what you were doing with log management? Because like this is a company where logging is pretty important. I imagine you have a ton of logs because there's so much data coming into the system. What was your log management solution beforehand?
Yeah, I think the thing that really changed for us with Scalar is that we could unify our logging and our alerting, where before they were separate. And we'd have like an alerting service that would check on various things and then page people if there was a problem, and logs were stored elsewhere and dealt with separately. But now, because we log so much, we can also just log health metrics. And then in Scalar, there are filters that will trigger on certain criteria if the health metric is out of whack. And then when something pages, you have the logs showing what actually happened at the same places where the trigger caused the page.
Can you tell me more? I want to hear more about the process of scaling this company, because you were started in 2012, 5 years ago. It sounds like there were bursts in popularity of Periscope data. What was the hardest problem in scaling the company that you encountered?
I think that the challenge has always been identifying and sort of staying true to who our core customer is. There are so many tools on the market that are going after less technical users, right? Who want drag and drop, who want measures and dimensions. And we've always had so much success with the data analyst and now the data team that focusing on them and making sure that we're serving them the best tools possible has really been a big part of the challenge and also a big part of the excitement. And that's why the Periscope is scaling.
So you're putting a stake in the ground and you're saying we are not for the less technical users. We are for the technical users who can write their own queries, the data teams.
Actually, I would say that we're about enabling the data teams to serve those less technical users. Because in a world where you only have those less technical users doing analysis, like you run into challenges where the analysis might not be correct. Like, for example, we're in different time zones, and let's say I'm building an analysis for you. It's a daily revenue chart. And when I send it to you, like, what time zone is that revenue going to be in? Because that matters how many dollars we made on Tuesday. And of course, did I include both databases because the legacy product is in the legacy database? And oh yeah, 2 months ago, the marketing team ran a campaign and gave away a bunch of licenses. And the way that's logged in the system is a bunch of revenue table and a bunch of credits in the refunds table. And this data didn't used to be this hard and this complicated. And so the reason we have professional data teams is to deal with that complexity and make that data accessible to the rest of the organization. And so Periscope is really about enabling data teams to wrangle that complexity and wrangle that volume of data so that the less technical users can be enabled to make the best decisions.
And how does the product management and development teams interact? So how do you where are you getting the feedback loop between the customer and your engineering team?
Yeah, so the whole company is incredibly customer driven. We have a 5-second chat response time where any customer can chat with one of our data analysts immediately. The sales team is constantly feeding back feedback. The account management and customer success teams are constantly feeding back feedback. And this all goes into our roadmap where the product team sort of wrangles all these sources of data, explores new questions with some of our strategic customers, and turns that into a roadmap.
And what about design? What role does design play? Because you're building a visualization tool. It's got to be well designed. How do designers factor into the process?
Yeah, so the design team is embedded with the product team. They're sort of one super team. And design does a ton of research, both competitively and looking for new usage patterns, as well as a bunch of user testing. So once we've identified a problem that is worth solving, that is strategic for the business, the product team as a whole will identify sort of who is already doing that, who's good at it, what can we learn from. And then we do a bunch of testing, both internally and externally, to make sure that the solution we come up with solves the problem.
Yeah, I'd like to hear your thoughts on some other data infrastructure type of stuff. So like I think of Spark, Apache Spark, and it seems like something that could potentially be useful to this type of problem, because I think of Spark as this tool that can can use distributed memory to get a working set of data into memory, and you can get a variety of queries answered against that. Have you evaluated Apache Spark as something useful to use?
Absolutely. And that's one of the things we'll be integrating later on in the process as we expand out the data pipeline. And it really comes down to operating the right data at the right part of the process. Where in the beginning, we spoke about like connecting to Salesforce, right? That code is going to be written in some statically typed language, pulled in on a regular basis, and almost never changed. And like Spark jobs will be written in a more sophisticated language than SQL, typically harder to operate because you want to be operating at massive scale and doing transforms in that sense. And Spark will be doing a lot of the heavy modeling. And then that'll get handed off to your SQL analysis, which does your groups and your counts and your filters. And of course, after that, you might have a Python or R do some transformations or some projections. And at the very end of the day, you've created these data experiences that can then be filtered and pivoted and drilled into. And at each step of the way, you can see how the engineering gets sort of more flexible, less rigid, and the systems become much more rapid to respond to user feedback.
And I imagine you see Periscope data as your window into this variety of tools where you can just write a query that feels simple on the outside, but under the covers, it's pulling together an entire workflow of different tools.
Yes, very much. Like the Periscope platform is a workflow platform where we'll help you go everywhere, all the way from ingestion to like visualization and reporting.
And these workflows today in a big company, I think they're managed by tools like Airflow and Luigi. Is that right? These kind of very technical tools.
Yes, but in fact, Airflow is only one piece of the workflow. Airflow handles a lot of the modeling, but you have to give data to Airflow and you have to tell Airflow where to put it. And so it's missing the ingestion piece and it's missing the storage piece. And so what we see long term is Periscope either integrating with Airflow or something like it so that you can do that style of modeling in the product, but also have the ingestion piece and the storage piece and the visualization piece.
So what, Airflow, we've done a show on this as an Airbnb or a tool that came out of Airbnb for workflows. Okay, let's just explain from a top level point of view, what is a type of query or a type of task that a random company, like an insurance company, for example, that doesn't have the infrastructure of an Airbnb, the engineering team of an Airbnb, what kinds of queries are they unable to do, or what kinds of data infrastructure are they unable to build because this type of stuff has not been commercialized?
It's really about asking the next question, right? Right now, they probably don't have access to all of their data. And if they did, the queries would take a long time to run. And so with a platform like Periscope, we want to give them access to all their data in a very rapid, like iterative framework. This way, when they do ask that first question, they're not done, right? They can go ask 10 more questions as part of drilling into that analysis.
Okay, so if I'm an insurance company, what would those questions be?
So I'm guessing an insurance company probably has really good data on like their core business, but they might not have the ability to connect that data, like the actual insurance plans, to the campaigns they're running, to the direct mail campaigns they're running. And so letting them connect all those data sources together to realize that this direct mail campaign influenced this city, which influenced this marketing campaign, which then influenced these insurance plans, would help them further optimize their operation.
So it's like, if you've got two totally disparate databases, you've got a Mongo database over here, and you've got a SQL database over here, and a Cassandra database over here. It should not be hard to do cross-database joins.
Right, and that's part of what our ingestion layer helps customers do, is get all those disparate data sources into one place so that when they build the models can be fully informed by their whole business, not just the part of the business that has easy access to data.
Why is that hard? Why is it hard to do those cross-database joins?
It's hard to do it repeatedly, right? You can dump a CSV from 4 different data sources, upload that somewhere, and then do the analysis. But that's almost never what you want the outcome to be, right? Because you're building something repeatable. You're building an answer to a question that's going to be asked every day or every week or every month. And so what you really want is a reliable system that can continually consume all the data from various places, make it available for not just this question, but every future question on a repeatable basis.
Now, do you have to be picky about how much you cache? Because, if you were to go hog wild, if somebody plugged in all of their data connectors into Periscope data, you could get really greedy and you could build all kinds of indexes and, have columnar data, have more columnar data than is necessary. What's the right amount of data to cache?
I think it's usually more than you expect, because if you try to restrict it, you'll only have the data you need to answer today's questions. And tomorrow when the CEO asks you, hey, this other metric over here, what happened? If you have to go through the process of establishing a whole new pipeline to get all new data into the system, that'll really delay your ability to answer those questions. So I think you want as much data as possible, as accessible as possible.
Now, do you ever have issues where people are saying, hey, my dashboards are not loading fast enough, and is there a button they can click to just like buy more speed? How does that conversation go?
Yes, there is absolutely that button. You can always buy more speed.
Okay, give me a little more color on that. So if I've got a query or if I've got a dashboard that's going slow and I click the buy more speed button, what happens?
Yeah, we will increase the amount of hardware supporting your queries, right? We have these thousands of nodes. We can just add more to the cluster you're on. And within usually about an hour to scale up a cluster, your queries will run dramatically faster.
Okay. And what is that? Is that typically like replication, or what exactly is going on under the covers to speed things up?
So you can scale both vertically and horizontally. Horizontally being that we can scale out to multiple copies of your data on multiple different clusters. That usually helps with scaling concurrency. But if you have a query that's taking 90 seconds and you want it to take 9 seconds, that's scaling vertically. And that's growing the size of the cluster, adding more compute, adding more RAM, so that it can process that much data just so much faster.
And do you ever have people who say, well, I can't afford that, so I need to adjust my queries, I need to adjust my dashboards to make them, I don't know, I guess less demanding? Is that an alternative for people as well?
Absolutely. In fact, sometimes there's just not enough hardware on the planet to put behind a certain query because of the way it's written. And so our support team is frequently helping customers rewrite their queries to be much more efficient. And it's the same sort of idea as you have in standard software engineering, where the way to make something go faster is to do less work. And so that means either scanning less data or scanning data in n time instead of n squared time kind of thing.
Now, machine learning is obviously a buzzword, well, depending on who you ask. Are there any interesting things going on around machine learning in your company, either ways that you're allowing people to learn from their data within Periscope Data, or are you using machine learning internally to build, I don't know, better scalability? How do you think about that term, machine learning?
Yeah, we use machine learning internally to do a lot of scoring on the marketing side, like the value of a lead, the value of the prediction of a contract, the prediction of churns. We don't currently enable machine learning in the product, but that is absolutely something we'll be doing long term.
Okay. Well, I know recruiting, it has an interesting process within Periscope Data. Tell me how you do hiring.
Yeah, so with hiring, we try to take a different approach than most companies, especially on the engineering side. We never ask folks to invert a tree on a whiteboard. That's just not a normal thing to do. It doesn't teach us anything. It's not fun for the candidate. I don't know why some companies do that. Instead, we invite the candidate in and they sit down with our team. They sit down in the engineering area and they pair with a few folks during the day to actually build like code together. And the project is quite fun, I think. And candidates really get an experience for what's it like to be a part of the team, what's it like to work on a code base very similar to Periscope's, what's it like to just sort of feel the culture and atmosphere at the company.
I guess you have seen the results of that versus the results of the recruiting process at Microsoft. Microsoft is much more of a invert the tree type of process. How does that contrast in outcomes?
Yeah, so we have a really kind, really positive culture. Our accept rate for engineering offers is over 80%, and it's every single time it's because of the people. Like when folks join, they say they joined us because of the team, because of the interactions they had while they're on site. And so I think that really lends itself to building a company that you can be proud of the culture and you can be proud of the people that work here, versus one where folks are super good at inverting trees on whiteboards.
Okay, fair enough. Well, Tom, I know we're running out of time, but what are the biggest challenges for Periscope Data for the future?
I think that the challenges is really how much can we get done and how soon. We have what I think are the best people. We have an incredible product in the right space, and it's really ours to lose. It's like how well can we execute is the challenge.
Do you have any internal, I guess, personally, how do you seize the day? How do you seize the opportunity? Because that's more of a philosophical question. How do you make sure that the company doesn't stumble and fall? What are your internal checks against that?
Yeah, so we're well past the scale where I individually can sort of run that process. And so it's really been about just hiring really smart, really experienced people who have seen some of the challenges we've seen before, who know how to grow teams, who know how to build the right process for our scale, and letting them operate what has become like a very large, very powerful machine.
Any hard lessons that you've had to learn around the hiring and management side of things?
Hiring and management is a very human process. In that sense, it is incredibly messy at times. And so I think any mistakes we've made have had to do with not thinking about the individual human characteristics of people and how they interact, and instead focusing on something else.
You got any book recommendations for getting better at that psychological understanding? Or is it just firsthand falling on your face?
My co-founder learns through books a lot. I'm sure you have great recommendations. I tend to learn by falling on my face.
Okay. All right, Tom. Well, it's been great talking to you. I've heard such amazing things about Periscope Data. I haven't used it firsthand, but I will be following the company closely, and maybe we could do some more shows with different members of your team in the future.
That sounds great. And thank you again for having me on.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver content to the listeners on a regular basis.
Wow!